Alright, welcome back. We're going to look at Unit 1, Day 4, dealing with linear regression today. We're going to need a graphing calculator to do some of the problems here. So, a linear regression is basically a statistical tool to model predictions. So graphs of data pairs for a real-world situation rarely fall in a line. Their arrangement, however, can suggest a relationship that you can model with a linear function. You can then use the function to draw conclusions about the situation. So we have some types of correlation, and they involve scatter plots. A scatter plot is a graph that relates two sets of data by plotting them as ordered pairs. You can use a scatter plot to determine the strength of the relationship or correlation between the data sets. The closer the data points fall along a line, the stronger the correlation between the two variables. Now, what we have here are different types of correlation. So, the first thing I want to make sure that we all understand are these lines here. The line you see in the scatter plots above is called the line of best fit. This line usually cuts the data in half-ish and can be used to make predictions about the future and past values for the situation. A graphing calculator can be used to find the best fit. So this is going to be very important because we're going to need a graphing calculator to find that. So what we see here is that the line of best fit is trending positively. So therefore the line is going to act like this. And whenever the points are close to the line of best fit, we have something called a strong positive. For this one, we know that this is trending in the positive direction, but the points are not all close to the line of best fit. So we call that a weak positive. Now, when the scatter plot shows the points all scatter around, it's not in one specific area, just like you can see right here, it's a no correlation. And here we can see that both of these graphs are trending negatively. So this one right here is a weak negative because not all the points are close to the line of best fit, but the one to the right here, it shows all the points are very, very close to that line of best fit. So here we have a weak negative, and then we have a strong negative. So before we talk more about that, we need to go ahead and talk about this. It's called Pearson's correlation coefficient R. Now, Pearson's correlation coefficient R helps us determine what type of relationship is occurring. So the R value can be between -1 and +1. Now, the closer R is to -1 or 1, the stronger the relationship between the two variables. The closer R is to 0, the weaker the relationship between the two variables. The sign of R tells you whether the relationship is positive or negative. So if we look at these examples here, we have that R is equal to 0.85, R equals -0.1, R equals 0, R equals 1. So the first example here, we know that this is positive because it doesn't say negative, right? So this is positive. And 0.85 is pretty close to +1. So we can go ahead and say that this is not just positive, it's a strong positive. So I'll write strong positive because this value is positive and it's close to 1 in terms of this. So now let's take a look at this example here. R is equal to -0.1. We know for sure that this is a negative, right? And this value here is not close to -1. So we call this a weak negative. Okay, so the next example is R equals 0. R equals 0 is not close to -1 and 1 in this sense. So whenever we say that R is equal to 0, rule of thumb here is we call this a no correlation. And then r equals 1. The r value is exactly 1. So whenever we have something like this, we call it a perfect. And since this is a positive one, it's a perfect positive, which in the real world does not exist. No such thing as a perfect positive in the real world. So let's take a look at some examples here. Example number 1, use the given equation to find the indicated value. Number 1 says you run a linear regression and it produces the equation y equals 3.24x minus 45.78. Find the value of y when x is equal to 4. So this equation is given. So if this equation is given and we're looking to find the value of y when x is equal to 4, all I need to do is replace x with 4 so I can find y. So all I need to do here is this. I do y equals 3.24 times 4 minus 45.78. And 3.24 times 4 is 12.96 minus 45.78. And then once I put this in the calculator, you're going to get negative 32.82. And that is our y value. Number 2, you run a linear regression and it produces the equation y equals negative 0.25x plus 57.5. Find the value of x when y is 15.5. So the equation is given again. And we're being asked to find the value of x this time when y is 15.5. So all I need to do is replace this y with 15.5, solve for x, and then you should be good to go. So here we go. We have 15.5. So remember, I'm replacing the y value with 15.5. I'm not replacing the x this time because that's what I'm trying to solve. So 15.5 equals negative 0.25x plus 57.5. Now remember, I need to get this thing by itself. So what do I need to do? Well, I need to subtract both sides by 57.5. So we know that this will cancel. So I'm left with 15.5 minus 57.5. That's negative 42 equals negative 0.25x. And then I'm going to divide both sides by negative 0.25. So I'm left with x equals negative 42 divided by negative 0.25. We know that a negative divided by a negative cancels, so 42 divided by 0.25 is 168. So that is your answer. All right, so we're going to flip to the back side of the notes. We're going to use a graphing calculator to find the line of best fit. So in order for us to run a linear regression, we need to make sure that we turn the stat diagnostics on. So let me go ahead and outline the steps for you. So in order for you to turn the stat diagnostics you need to follow these 3 steps. So the first step here is you need to find the mode button and press it. So press mode. And then 2, you will press stat diagnostics and then make sure that it is on. So let's go ahead and do that right now with our graphing calculator. So I'm going to go find the mode button. It's right next to the second button. All you have to do is just press the mode button. And then this is the screen that you're supposed to get on your graphing calculator. So you're on normal right now. We're not going to mess with anything in this row, but we're going to scroll all the way down until we see stat diagnostics. All right, so here we go. Stat diagnostics. Now notice that we have two buttons, the off and on button. It looks like my graphing calculator shows that this is already on, but if yours is not, make sure it is. So in order for you to do that, make sure that you arrow to the right, press enter so that it's enabled, and then you're going to quit by pressing the second in mode button. So you're on this screen. So now that we made sure that the stat diagnostics are on, we have more steps to put on our paper. So we need to make sure that we run a linear regression. So the first step here is stat edit to put x's in L1 and y's in L2. 3, stat calc lin reg in the form ax plus b. And 4, write your equation of the line of best fit. So, number 3, it says the table shows the number of hours students spent online, not working on school the day before a test, and the scores on the test. So, we have numbers of hours online and test scores. So the number of hours online deals with X values. Those are the numbers we're going to put under the L1 button. And then the test scores are our Y values. Those are the numbers we're going to put under L2. So we're going to run a regression on our calculator and find the equation of the line of best fit and find R. So we already made sure that the stat diagnostics are on, so that's good. Now, one thing that we need to do is find that stat button. It's under the word delete or del. So press stat. Then you're going to hit enter because you want to press the edit button. And then you have L1, L2, L3, L4, L5, and L6. We are going to mess with L1 and L2. So remember, all the X values, which in this case, the number of hours online, are going to go under the L1 column. And then our test scores are our Y values, which we're going to put under the L2 column. So we're going to go ahead and press 0 because that is our first X value. So 0, enter, and then 0 again, enter. Then we have 1, enter, 1, enter, 1.5, enter, 1.75, enter, 2, enter, 2, enter, 3, 4, 4.5, and then 5. So we have all the X values under L1. We're going to go ahead and arrow to the right, and then move on to L2. So our first test score is 100, enter, 94, 98, 88, 92, 89, 75, 70, 78, 72, 57, and lastly 60. So now we have all the values inputted. So now what we're going to do is we're going to press the stat button again. Then we're going to arrow to the right once so that we see calc. Then you need to scroll down to lin reg ax plus b. So press enter and enter, and you should get these values here. So we ran a regression on the calculator, and now we need to write the equation of line of best fit and the value of R. So notice that this is in the form y equals ax plus b. So y equals ax plus b. What we need to do here is replace the a value and our b value. So the a is given and the b is also given. So A is negative 7.907 blah blah blah, and B is 98.05 blah blah blah. So what we're going to do with each of these values is round to 3 decimal places. So with my A value, I have negative 7.907x plus 98.051. So this is my equation of the line of best fit. But we're not done because we need to find R, but R is already given to us. R on the calculator says it is negative 0.904. So it says describe the correlation based on R. So looking at this, it is a negative number, and this value is closer to negative 1. So if R is negative 0.904, then we can say that this is a strong negative. So this is a strong negative. Now, C says if someone spent 3.5 hours online, what would you expect his or her test score to be? So what I need to do is I'm going to use this equation that I found on my calculator and replace the x value with 3.5, because we know that hours are the x values, and since this number is part of the domain, then what we can say here is, okay, let's just replace x with 3.5 to find what the test score or y value be. So I have y equals negative 7.907 times 3.5 plus 98.051. So negative 7.907 times 3.5 is negative 27.6745 plus 98.051. Add these two numbers, you get 70.3765. But we're going to go ahead and find the test score. So let's just round this to a 70%. So I'm just going to say this: he or she should get around a 70% on this test. Alright, so number 4, you research the average cost of whole milk for several recent years to look for trends, because why not research whole milk? The table shows the table from all your hard work. So there's a relationship between the years and average cost for 1 gallon. So remember, time always deals with x values. So we're going to write x for years and y for average cost for 1 gallon. So A says run a regression on your calculator, find the equation of the line of best fit, and find R. So remember, we're going to go ahead and follow these steps here. So we're going to press stat, edit, and we have the L1 and L2 inputted because of the last problem. So what we're going to do is we're going to scroll all the way up to L1 and then press the del or delete button, and that should clear up the column here. And then we're going to do the same thing by arrowing to the right for L2 and then delete. Now going back to L1, we need to input our x value. So we have the years, and then we need to make sure that we scroll down once so we can input stuff for L1. So I can go ahead and press 1998, 2000, 2002, 2004, 2006, 2008, and then we're going to arrow to the right and then make sure that your graphing calculator is highlighting the dashed lines here, so you can input 2.65, 2.89, 3.00 or 3, 3.01, 3.20, and 3.77. And then we're going to press the stat button, arrow to the right, and hit calc. Scroll down to linreg ax plus b, not a plus bx. Hit enter, enter again, and then, okay, so we're going to write our equation of the line of best fit and then find the r value. So remember, it's in the form y equals ax plus b. It's basically y equals mx plus b, same thing. So remember, we're replacing the a and the b values, and we're rounding to 3 decimal places. So for a, we have 0.093x plus, well, we have plus negative 184. So basically, this is going to become minus, so minus 184.051. So then we have our equation and the r value. So we have r equals 0.9196, and the reason why I have 4 decimal places is because of the 6 here. The 6 is going to change the 9 to a 0, and since this 9 turned into a 0, this thing gets increased by 1. So your r value is actually 0.92. So describe the correlation based on r. We know that this is a positive number, and 0.92 is very close to 1, so this is a strong positive. So based on your linear model, how much would you expect to pay for a gallon of whole milk in 2020? So we have the x value, and we're trying to find the y in this case. So I have y equals 0.093x minus 184.051, and I'm going to replace this x with 2020. So 0.093 times 2020 minus 184.051. I'm going to use my calculator to figure out all this. So 0.093 times 2020 minus 184.051. And I have 3.809. So that means the milk should cost about $3.81, right? Because we don't say $3.809, right? We round that to 2 decimal places here. So 3.81 or $3.81 in 2020. So the milk should cost about $3.81 in 2020.